Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Let's try to apply the iterative formula knowledge in solving this question. This past year question is question of the year May-June 2002. According to the question, the sequence of values given by the iterative formula is given here. With the initial value also given, x1 equals to 1, it converges to alpha. The alpha is the answer that we are looking for, which is the root of this equation. So for the part 1, use this formula to find alpha, correct to 2 decimal places, showing the result of each iteration. So the working for this is very simple. So first, we start with a 1. This is our x1. Second, we are supposed to find x2. So to find x2 means that we need to sub x1 into here and here. So the working should be 2 over 3 times with 1 plus 1 over 1 square. The answer should be equals to 1.3333. It's better to leave your answer here 2 decimal places more than the final answer that is requested, because later on when you round up the answer here, it's easier for you to check when to stop. And remember, just now I have taught you the method. All the x here, change it into the answer button in your calculator, so that when you are finding the x3, you just need to press a button, the equal sign. Then you will get the answer of 1.2639. There's no need for you to show this working again, as you have shown in the x2 there. So for the following x3, x4, x5, you just need to find the answer and write the answer straight away. So for the x4, it should be equals to 1.2599. And have a look here. When you round up to 2 decimal places as requested by the question, it's 1.33 in the x2. And for the x3, it's 1.26. x4 is also 1.26. So here we can know that actually the answer is 1.26. This sequence actually converges to the alpha, which is 1.26. But if you want to double check your answer, you can press one more time to get x5. It's still 1.2599. So here we can conclude that this sequence converges to alpha with the value of 1.26, correct to 2 decimal places. That's how we make use of the iterative formula in solving this question. As for the part 2, you are asked to state an equation satisfied by alpha, and hence find the exact value of alpha. So for the part 2, this part here, they want the original equation that's satisfied by alpha instead of having the iterative formula. So how to get the original formula? Still remember just now how we change this formula, how we change this equation into iterative formula? We just rearrange it into this form, and then we add in the n plus 1 and the n to get this iterative formula. So now what the question wants here is the original equation that's satisfied by alpha. So from the iterative formula here, to get back to the original equation, we just need to get rid of the n plus 1 and the n and change everything back to x. So for the part 2, the answer is actually x equals to 2 over 3 x plus 1 over x squared. That's the original equation that is satisfied by alpha. Alpha actually comes from this equation, the root, the solution of this equation. And now, Hence, find the exact value of alpha, which means you are asked to solve this equation without using the iteration method. So to solve this equation, just as usual, the whole equation, both sides multiplied with a 3, then you get this, and then the 2 you move over to the other side, and you get this, and the x move over, you will get this. So the x squared multiply up, and the 2 bring over, you get x cubed equals to 2, and hence x equals to cube root 2. As requested, you are asked to leave your answer in the exact form. That's a solution for this equation. So now let's try to check what's the value of this cube root 2. If you use your calculator and check for the value, it should be equals to 1.25992105, which is the same as this solution. So for this equation, actually can be solved algebraically, or if you want to use the iterative formula, you can use the iteration method to solve to get the root. Eventually, you should get the same root. Let's try on one more question. Have a look at the question October-November 2005. So for this question, you are given the equation x cubed minus x minus 3 equals to 0, and there is a real root of alpha. So for part 1, you are asked to show that the alpha lies between 1 and 2, means that the real root lies between 1 and 2. So for this question, it's a very common question in this chapter, the very basic common question that you must know how to answer in this chapter. So how to show that the root lies between 1 and 2? What you need to do is show that there is a change in sign. The keyword is change in sign. Why we need to show that there is a change in sign? Because let's say this curve, cubic curve, is something like this. So they ask you to show that there is a change in sign, there is a root. Let's say the root is over here. There's a root in between 1 and 2. So what to do is, we just need to substitute the 1, x equals to 1, into the equation to get the y value, and substitute 2 into the equation to get the y value. So if one y value is positive, the other y value is negative, that means for this curve, confirm that it will pass through the x-axis. That means the root, there must be a root in between 1 to 2. Alright, so now let's try the part 1. The first thing, what to do is we let y equals to the equation x cubed minus x minus 3. You have to make sure that the equation is arranged so that it's equals to 0, then only you can let y equals to this part. Then what to do now? Because they ask you to show that the root lies between 1 and 2. So what to do is you substitute x equals to 1 and x equals to 2 into the x to get the y value. So when x equals to 1, the y should be equals to negative 3. So when x equals to 2, the y value should be equals to 3. So from here, you can see that 1 is positive, 1 is negative. Then you can mention that there is a change in sign. Therefore, alpha lies between 1 and 2. That's how we do it. The keyword here is change in sign, and you have to show that there is a change in sign. That's how we solve for part 1. As for the part 2, have a look here. There are two iterative formulas derived from the equation A and B. So two iterative formulas are given. So each formula is used with the initial value x1 equals to 1.5. So now the x1 value is given. So for the part 2, they ask you to show that one of this formula produces a sequence which fails to converge, and then you are asked to use the other formula to calculate alpha. correct to 2 decimal places. Give the result of each iteration correct to 4 decimal places. So there are 2 iterative formula here. One fails to converge and the other one will converge to get the alpha value. So let's try the A first. So initial value is given here, x1 equals to 1.5. So we just need to find out x2 by substituting the 1.5 into the x here. So it's 1.5 cubed minus 3. So when you press using calculator, you should press 1.5 and equal in your calculator so that you can make the 1.5 as the answer in your calculator, and then key in this equation and change the x into answer. So we should key in answer cube and minus 3. So the next answer should be 0.3750, 4 decimal places according to the question here. Then press equal again to get x3, which is negative 2.9473. x4 is negative 28.6011. It seems like this sequence is not converging. The value just gets more and more negative. So let's check for the x5. It's negative 23399.2411. So from here, it's very obvious that this sequence actually fails to converge. And we actually call it diverge. So that's by using the iterative formula from the A here. So now let's try the iterative formula from the B. This is a A, this is from the B. So same thing, start with x1 equals to 1.5. Then we are supposed to find out what is x2. And we just need to sub 1.5 into here. So we can have 1.5 plus 3 power 1 over 3. So as usual, when you key into your calculator, set the 1.5 as the answer in your calculator, and then you just need to key in this part. So bracket, change the x into answer, so answer plus 3, close the bracket, and power 1 over 3. Then you press equal sign, you will get the answer as 1.6510, 4 decimal places. And then x3 is 1.6692, x4 1.6714. From here, actually you can see that it starts to converge. So x2, when you round up to 2 decimal places as requested by the question, is 1.65. This one 1.67, and here 1.67. Actually we can stop here, but just to double confirm, we can find out the x5. It's 1.6717. So still, when you round up to 2 decimal places, it's 1.67. And hence, we can conclude that this sequence actually converged to a fixed value, which is alpha equals to 1.67. That's the answer for the part 2. So that's all about the iteration, how to use the iteration method, and how to make use of the iterative formula. That's all for the lesson today. Thanks for watching.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub, will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.